Hi all, welcome to the next video in our week 1 series on measures of center. There are several measures of center. We've actually already talked about one, and there's 3 we're going to talk about in this video, but we're going to start by focusing on 2. The first is called the mean. When most non-stat savvy people talk about an average, this is the number that they're talking about. And more specifically, it's called the arithmetic mean, and we'll see why it gets that name in a second. But let's talk about some important features of the mean. First, to find the arithmetic mean, we add up all the values, then divide by the number of values. Next, because we are actually adding up each one of the data values, this value is more heavily affected by a presence of outliers in your data set. So outliers are going to shift the mean more than the other measures of center we're going to talk about. Because of that, the mean is generally best when used with symmetric distributions. Distributions that if you cut them in half at the midpoint and you fold them, you get 2 perfect mirror images. The upside for us is that most of the distributions that we're going to use in this course are symmetric. So our default measure of center for this class is going to be the mean. The other that we've talked about previously is the median. This one divides the list into 2 equal count parts. And you'll remember we did this by sorting the list and then crossing off values till we ended in the middle. But we didn't care what those values were, we just cared about where they were in the list. Because of that, because the median doesn't actually look at what values are in the list, just where they sit, it's resistant to the presence of outliers. If you've got outliers in a data set, the median isn't going to shift as much as the mean will. That makes the median a really good choice for distributions that are not symmetric or that have outliers. Let's look at some symbology and how to calculate the mean. That we've already done for the median, and if you've forgotten, you can go back and speed through video 111. So let's talk a little bit about notation. This is one of the big stumbling blocks for people who are new to statistics. So this is definitely important, and you want to jot this down. So we can calculate the mean using sample data pulled from a small subset of the population we're interested in, or we can calculate the mean based on all of the data from the entire population. If we are using sample data to calculate the sample mean, we use the symbol x bar, which is just the English letter X with a bar over it. Because it is a value calculated from sample data, it is a statistic. The value calculated from population data is represented by the Greek letter mu. So it's like a U, but it's got a long tail in front. This is a population parameter. Sometimes you will hear this called, instead of the population mean, you'll hear it called the true mean. And in statistics, anytime you hear that value true in front of a calculation, that's telling you that calculation is based on population data. So in your head in this class, anytime you hear true, think about population. It means that we pulled that value from all of the available data. So let's look at how to find the mean for a list of raw data. If we're doing it by hand, we're going to add up all the values and divide by the number of values. It's exactly the same for both the sample mean and population mean. The only difference is if you're calculating a population mean, that list of values is likely to be a lot bigger. So for example, we want to find the mean for the sample data shown below. We've got a list of numbers from 1 to 4. So I counted 11 values in that list. So I know when I get to step 2, I'm dividing by 11. For step 1, I have to add all those numbers together. So 1, 2, 3, 5, 7, 10, 14, 18, 22, 26, 30, assuming that I can count correctly. And you can see I wrote that addition out longhand here. And you'll notice that I use the symbol X bar. I'm using the symbol X bar because this example specifically said sample data. And sample data and sample statistics typically use English letters. So I want the X bar, not the Greek mu. That's good. Apparently my past self used a calculator also got 30. That's a good sign. And we do 30 divided by 11, and we get 2.7. So the mean, or the average of this data set, is 2.7, somewhere between 2 and 3. With a calculator, we're going to see some familiar steps here. So if I want to find the mean for a raw list of data with the TI-84, it is exactly the same steps as finding the quartiles. You go stat, edit your list, dump all of that data into list 1, and then go stat, calc, 1var stats. One of the first values, and it might even be the first value the calculator spits out, is that mean. But you should note that your calculator is going to report that mean as X bar, even if you supplied it with population data, because the calculator can't tell whether you entered population data or sample data. And in terms of the code that it's running on, it doesn't matter because the equation is both. And so it defaults to X bar. It's up to you to make sure you're using the correct symbol on your paper. You're going to see a similar issue in GeoGebra. It's going to say the mean equals a number, and it's not going to indicate the appropriate symbol. So you will need to either use X bar or mu, depending on whether you were given sample or population data. For GeoGebra, you'll notice step 1 is the same as it was for the median, and we're going to see this step repeatedly throughout the course. Dump all of that data into a list. So list name equals data in curly brackets, press enter, and then to calculate the mean, it's just mean, and then in parentheses the list name. You will know it's a lowercase, words are hard. You will notice a lowercase m here. This is one of the few function calls that's lowercase instead of uppercase. I don't know why, but it should indicate that once you start typing mean. So hopefully not too hard to remember. If not, there's GeoGebra guides on Canvas. Okay, so we're going to do this with a calculator. We've got AIDS data indicating the number of months a patient with AIDS lives after taking a new antibody drug are as follows from smallest to largest. Calculate the mean and the median. This list is much longer than our previous examples, so this is what I'm going to grab my calculator for. And we're going to clear our screen. And for the calculator, we need to hit stat, enter, and I need to clear out my list. So clear, enter, and then we need to type our data. So let's see if I can scoochy this off far enough that I can see it. No, I can't. So I'm going to pull this off screen for a minute while I type, and then I'll bring it back over. Okay, so I've got the last of that data in my calculator. Now I'm going to run that 1var stats program. So stats, calc, 1var stats, My data is in list 1. My frequency list is blank. And you can see that the first thing it spits out, my mean is 23.575. Using the rounding rules that we mentioned in a previous video, since all of my data was whole numbers, I want to round that to the 10th place. And looking next to that 10th place is a 7. So I'm going to round that up to 23.6. So we know our mean is 23.6. To get the median, it's already on my screen. I just have to scroll down, and we can see the median is 24. So 23.6 and 24. You'll notice those values are fairly close together. 23.6 rounds up to 24, but they're not the same. Typically what that tells us is that our data is not perfectly symmetric. If I fold it at the halfway point, I'm not going to get two perfect mirror images. The further apart those numbers, the more wonky the graph, and we're going to talk about that in a later video. So that's great for a list of raw data. What happens if somebody gives me a frequency table? Those are something you can do by hand. I'm not going to cover it because it's tedious and I'm lazy. It is in the book, and if you are curious, drop by office hours. I'd be happy to go over it with you, but I want to focus on using technology because that's how most people do this. So if you're using a TI-84 like I'm using, you're going to start in that Stat Edit List menu. And we're going to create 4 lists. So we're going to start with the lower boundaries of each class in L1 and the upper boundaries of each list in L2. Now what I actually want are the midpoints to represent each class. So I'm going to use the calculator to do that midpoint calculation for me. I'm going to move the cursor over and up to L3 so that L3 is highlighted with my cursor. And I'm going to type a formula in. Parentheses L1 plus L2, close parentheses, divide by 2. And you'll notice that as our midpoint formula, lower bound plus upper bound divided by 2. After that formula is typed, if you press enter, you're going to notice that list 3 auto-populates with the midpoints. So that calculator is going to do the heavy listing for you. And once you've got the midpoints, you just need to move over to L4 and enter the frequencies. In the past, I've had students ask, do I need to do steps 2 and 3 if I already know the midpoints? And the answer is no. If you already know what the midpoints are, either from drawing a frequency polygon or because the number set is really easy to interpret and you can do it in your head, you can put the midpoints in 1 and the frequencies in 2 and do what we're doing. You'll just have different list names. I would encourage you to do this entire 5-step process to get all 4 of those lists filled in until you're super comfortable with how to use your calculator. Now that we've got midpoints and frequencies, those are the 2 lists that we want to work with. And we're going to go back to Stats Calc 1var Stats. The difference being now the data values that I want to count are in list 3. I want to treat all of the data points in a class as if they're at the midpoint. And then I have a frequency list. I need to tell the calculator how many data points are in that class or at that midpoint. Once you hit calculate and enter, it should run that calculation, and it's going to spit out that mean as an X bar, just like you did for raw data. GeoGebra is very similar. You need 2 lists, lower bound, upper bound. I typically call them A and B. And then in a new line, you're going to enter a formula. M equals, that M is the name of our new midpoint list. And then a plus b divided by 2 is the midpoint formula. So when you type this exactly as appears on the screen in GeoGebra, it should then produce a list, m equals curly brackets, and then the list of midpoints. In the next box, you're going to type f equals, and then your list of frequencies. And then you're going to call the mean function mean and give it midpoint list name, frequency list name, m comma f. Let's go ahead and do that. So we've got this example, a frequency table displaying Professor Blount's last statistic test is shown. Find the best estimate of the class mean. So a fancy way of saying use your calculator, find the mean for the grouped data. I'm going to do it on the TI-84 because I think it's a little bit more finicky. But there are directions in Google Classroom for GeoGebra, and you can come by office hours and I'll show you. So step 1, stats, edit, enter. I'm going to go through and clear out all 4 of the lists that I need. List 1 and list 2 are clear, clear list 3, and clear list 4. For most of you, if you haven't used your calculator before, those shouldn't be filled in. And then we're going to start by entering lower class boundaries in list 1 and uppers in list 2. Okay, quick time skip forward. I've got list 1 and list 2 in my calculator. I now want to create that midpoint list in list 3. So I'm going to go over, and then I'm going to go up so that my cursor is on L3. And I'm going to come down to this box, and I'm going to start entering that midpoint formula. So parentheses, and then list 1 plus list 2. Close the parentheses, divide by 2. And as soon as I hit enter, that calculator automatically fills in those midpoints. My last step, we're going to enter those frequencies into list 4. So another time skip, you can see my frequencies are in list 4. You can also see as I work my way back across this table that all of my lists are the same length. That's important. If your lists aren't the same length, when you try and use one-var stats, your calculator is going to spit back an error message. So now I want to run one-var stats on my midpoints and my frequencies. So I'm going to hit stat, calc, one-var stats. My midpoints are now in list 3. And my frequencies are in list 4. And I'm going to hit enter. And you can see that my mean is 76.86. I want to round out to that hundredths place, that second decimal, because the information in the table goes out to the first decimal. So 75 or 76.86. Words are hard. You will notice that I used a mu here. I used the symbol for population data. And the reason I did that is they're asking us to find the best estimate of the class mean. And this is the data from the entire class for Professor Blount. If I have all of the data for the group of interest, I just calculated a population value. So this is a mu. I'd like you guys to pause the video really quick and try and calculate the mean for this set of group data, and then I'm going to go through the solution. So when I ran this data in my calculator, I got a mean of 9.49. And again, you'll notice that because the hour data was given to the tenths place, I rounded my answer to the hundredths. And in this case, it says that Maris conducted a study on the effect of playing video games has on memory recall. And specifically, she looked at hours of teenagers. There's an assumption based on the numbers in the table that she did not, in fact, interview every teenager on the planet. So in this particular case, with her interest population being teenagers, and this sample size being so small, it has to be a sample. So this is an X bar. Okay, I think this is the last slide. Really quick, the mode is another measure of center. And the mode is simply the data value that repeats the most in your data set. To use more recent vocabulary, the mode is the value in the data set with the highest frequency. If your data has been grouped for you and you're looking at a frequency table instead of raw data, instead of having a mode, we have a modal class. And the modal class is the class or category with the highest frequency. You can find this by hand using a sorted list. The TIs don't have a mode command. You'll notice it doesn't pop up on that list that you get from 1VAR-Stats, but GeoGebra does. So you can use the TI-84s to sort your list, but you'll have to manually search it for the highest number of repeats, or you can use GeoGebra and do mode parentheses list name. Okay, that's it for this video. If you have questions, let me know. I know we're probably getting into the point in the week where you're looking at these videos and go, oh my goodness, will he stop talking? I promise that this is the longest week of the semester because we're blazing through all of descriptive statistics in 1 week so that we can spend a lot of time on the more difficult topics and go nice and slow at the end where most students tend to struggle with the stats. So that is why there's so much content in these videos. I promise it won't be like this for the next 6 weeks. But again, if you're stressed out or you have questions or you need help, let me know. Otherwise, I'll see you in the next video.